Now, computational thinking is made up of four different elements, which are decomposition, pattern recognition, abstraction, and algorithm design. Now, decomposition, what exactly do we mean by decomposition? Decomposition is a way of breaking down a problem. So anytime you're provided with a problem in computing, you got to decompose the problem. You got to break down the problem into a simpler form. Do a thorough analysis of the problem. So decomposition is similar to analyzing the problem. To analyze means breaking down the problem and understanding the problem. So that's what it means. And we're going to be doing that today. Furthermore, for pattern recognition, after breaking down the problem, you have to study the similarities and the differences among the various components of the problem. Okay. And then remove those parts, those elements of the problem that cannot be solved using computer. You remove them and then present them into a form understandable by the computer, and this is known as abstraction. When you remove the unwanted bit which cannot be solved from a problem, so that at least the computer can understand precisely how to solve the problem, this is known as abstraction. Okay, and it's a general principle we use. Not every day-to-day problem can be just solved like that by computer. We just have to do some processing, removing the unwanted bits, the unsolvable bits, or convert them into a form which a computer can understand. So please understand what abstraction is all about. Now, the algorithm design, after understanding the problem, is important to come up with a set of instructions on how the problem will be solved. Okay, so after enumerating all the steps, we have to arrange them orderly, sequentially, so that the computer basically will understand how to proceed. That's all about computational thinking. So please remember, like I said, computational thinking contains three elements: decomposition, you break down the problem; pattern recognition, you find out the similarities, the differences among the various elements of the problem; abstraction, remove the various bits which cannot be solved by the computer, or convert them, if possible, to a form understandable by the computer, or remove them completely. And then algorithm design, which involve step-by-step instructions of what the computer needs to do. And please remember, for algorithmic design, they must be sequenced. It means they have to be arranged in order. I want you guys to have a look at this for a moment. Look at A. How many single squares faces in diagram A and B are there? How many faces? So you have to study it, analyze it, decompose it, and come up with a solution. I will do only A, then you do the B part as part of your classwork today. Now, in my own case, the way I will undo A, I will break it down into cuboids. As you can see, there are cubes here, and the top layer, if you look at it very carefully, contains 9 cubes. How do I know? 1, 2, 3. 1, 2, 3. So the length, 3 cubes. The breadth, 3 cubes. So if we multiply 3 by 3, that basically should give me 9 cubes at the top layer. The second layer contains the same, which is basically 9 cubes as well. And the third layer contains 9 cubes. So in a way, we have 3 9 cubes. That means we've got a total of 27 cubes there. Now, to do my analysis further, or to decompose the problem further, each cube, if you look at it very carefully, has 6 faces. So we need to multiply 27 by 6, and that should give us 162 faces there. So it means A has 162 faces. I can go over this problem again so that you see the problem is to find out how many faces we have in diagram A. What did I do? I first of all look at the diagram, the problem very carefully. I decompose the problem into cubes. For instance, we have 1, 2, 3, 1, 2, 3, and then we multiply this by that to get 9 cubes for the top layer, 9 cubes for the second layer, 9 cubes for the third layer, giving me 3 times 9, a total of 27 cubes. But each cube has 6 faces. So we've got to multiply 27 by 6. And that's basically should give me 162. 162 faces. So all I want you to do now, you need to find out how many faces are in B. This is the first computational problem I want you to solve. Think, look at the sequence. How many cubes? What do we really have any sequence there? Of course we do. So, and then do your calculation. Okay, so now we're gonna go further. What I want us to do right now is to have a look at applying computational thinking. And the first problem I want us to solve is to construct a bungalow, an estate of a bungalow. Actually, what I have here, these are not bungalows, these are houses, but the examples I will use will be based on creating bungalow, the top only, and then you will do the rest using your computational thinking. Now, the first thing I'm going to do here, I'm going to analyze this building. Okay. To analyze this building, I can see this building has got a roof. If you break down the problem into simpler form, it's got a roof. The building has got a wall and it's got a window. But the example, the illustration I'm going to be using, we only have a door here. Okay. So what I will do is I will do a simple analysis on how to solve the problem. So the analysis therefore includes, we've got the roof, we've got the wall, and we've got the door. Okay, I think I broke it down here. Here I have the roof, I have the wall there, and then I have the door. Now we're gonna do a more thorough analysis. So if we want to implement this now using Python, especially we're going to be using the Turtle package actually to draw this house. What exactly do we do? The moment we go into Python and then load the Turtle library, the Turtle basically will be pointing horizontally along this arrow here. So to draw the roof of the building, as you can see, the Turtle need to turn 120 degrees. You can decide on what the length here will be, but I'm just going to be using a 100 pixels for the length, the slanting height of the roof. Okay, and even though the top of the roof looks smaller than the slanting height, I will use the same length because I want to use iteration. Iteration basically is a procedure for repeating some steps in programming. So if I say okay, from there to there is 100 pixels, I also want to make this 100 pixels and also want to make that 100 pixels. Okay, so I have to look at the angles first. So first of all, the Turtle we turn left is going to turn left here 120 degrees and move 100 pixels and then turn again. But this time, as you can see, this is the original path of the Turtle. So if it's going to turn this way horizontally to create the top of the roof, it has to turn 60 degrees, as you can see. And here, this is the new path. It has to turn 60 degrees again to create something similar, a slanting height similar to the first one we created. But finally, because we're going to be using iteration, the turtle is going to be pointing towards this direction here. It's going to be pointing this way because my iteration is going to be 3. So it's going to do it the first time, 1, 2, 3. So it's going to be pointing here. So for me to complete the roof now, I have to ask the turtle to turn 60 degrees again and then draw the line. This line here, I believe, will be 200 pixels. And then we can shade the roof. Now let's see how we can implement this in Python. Remember, the turtle initially is pointing horizontally. It has to turn 120 degrees. And then we can repeat moving forward 100 pixels and turning 60 3 times. And when we do that, the turtle ends up here, pointing this direction here. And to complete our roof, like I said, it has to turn 60 degrees. So that 60 plus 60 will be 120. So it has to turn 60 degrees so that we can complete the roof. We can complete the line here. Alright? That's exactly what I'm going to do. So now, to do this, let's go into Python. For those of you who have not used Python before, simply go on your search bar and type Python and click on the IDLE, which is the Integrated Development Environment. I'm gonna wait for this. Okay, now this is loaded. Now that this is loaded, we will click on File and click on New, and this is where we're going to be typing our code. Now I want this code to be bold, to be readable, the text to be large enough for you to see. So I'm going to go on Options and configure it to make it a little bit bold so that at least you can see it. And we want to increase the font size, say to 16. I'll click on Apply and click OK. Now, before you can draw in Python programming, you need to import the Turtle package. The Turtle package is a library containing functionalities on how to draw. If you fail to import the Turtle package, there is no way you can draw anything in Python. Okay, so the first thing therefore I'm going to do will be to type import Turtle. Now when the package is imported, we want it to be stored in T. You can say, okay, you want the package to be stored in A, but since I want mine to be stored in T, I will say import Turtle as T. For instance, if you decide to store your own package in B, yours will be import Turtle as B. If you want to store your own package in C, it's going to be import Turtle as C. But I'm storing mine in T. Okay, now the shape of my turtle, that is the pen, do I want an arrow? Do I want a circle? Do I want a real turtle to come on the screen? So I'm gonna type T, because I know now my turtle package is in T. I will type T dot shape. Then I will type turtle. Okay. Now the color of my turtle, I want my turtle to be brown, so I will type T.color. Please note, the color I'm using here is the American color. The British spelling is COLOUR. You don't want to use that here because remember, this software belongs to the Americans, I believe. So this should be T.color, and then I will type brown there. Please remember to use speech mark around the parameter you provided. The parameter, whatever you type inside the bracket, is known as a parameter. Here, it's one of the keywords you need to learn today. Okay. Now remember, from our design, we said we need to turn 120. Let me just go back to it. So that you see precisely what I mean. We need to turn 120 degrees from our design here, because originally at the start the turtle is pointing horizontally, so we want it to turn in this direction, 120 degrees. Okay, so I'm gonna go back to my code and type t dot turning left, t dot left, that should be 120 degrees, because initially if I run it, you see the turtle will be pointing horizontally. Actually, I think I have to run this so that you see exactly what I mean. I'm just gonna run this and do it quickly. So we've got to save the data file first. Particle 6. Note that the turtle is pointing horizontally, but we want the turtle to point in that direction so that we can draw the slanting height of the roof. So to do this, we're gonna go back to our code and type t dot left 120. So now if I run it now by pressing F5, you see it will be pointing up. You can see it's pointing in that direction now, so you can see ready to draw. So we're gonna ask the turtle to move forward 100 pixels. Okay, so we're gonna ask the turtle to move forward 100 pixels. So to do this, we type but since this is going to be repeated 3 times, from what we have here, it's going to be repeated 3 times. It's going to move forward up to here 100 and then turn 60, and this will be done 3 times, as you can see. 1, 2, 3, and then it will be pointing towards this direction. So we're going to use what we call iteration. Iteration is a procedure. It is a mathematical procedure used in programming for repeated elements. Okay, so we use that. So I'm going to type for, you can say for K, for J, for P, you can use any letter for it. For I in range, the keyword there is range. We want it to do it 3 times, so I'm going to type 3 there and I put colon. For I in range 3, we will now say t.fd. Alternatively, you can type t.forward. It's the same thing. This is basically how you can draw a line. t.fd 100, and then we want it to turn left. t.left 60. So it's gonna do this 3 times. But now the roof will not be complete. But basically, I will run it so that you see exactly what I mean. It's gonna do it 3 times. You see, 3 times. It's done it. What we will do, as you can see, is pointing towards this direction, but we want it to point horizontally towards this direction. So the angle between the turtle at the moment and the horizontal is 60. Okay, of course it has to be 60 because the final turning was 60. So and then the other turning, 60 plus 60 should give us 120, which is equal to the angle of turning right from the beginning, because we said you should turn. You should do it 3 times. So we will ask the turtle to turn 60 degrees so that it will be pointing horizontally. Okay. So to do this, I will I will now type t dot dot left 60, and then we will ask the turtle to draw the line 200. So t dot fd equal 200. Okay, so if I run it now, the roof is complete. Perfect. So we finished drawing the roof. Now we can make this line thicker. To make this thicker, we need to change our pen size, basically. So I'm going to change the pen size now to, let's say, 2. To change your pen size, please do not put your pen size inside your iteration. So I'm going to put it in the main at the top. So we type t dot pen size. You can make it 3 or 2. So let me just make it 3. Okay, let's make it 2. 3. Alternatively, you can make it 2. It will still be fine. So if I run it now, it should be thicker. The drawing should be thicker than before. See, it's thicker now, which is good. Brilliant. Now, the next thing we need to do, we want to color the roof of the building. Let's color it black. To color it, we will use the fill function of the turtle. We color it because basically the roof starts from here. Okay, the roof starts from here and it ends here. Okay, it starts from there and then ends here. So we need to enclose the roof using the fill color. So at the top of the roof, the code for the roof, we're gonna type t dot fill color. Type that, and what color do we want for that? We're gonna type black. Please make sure you use speech mark there, and then we're gonna type t dot begin fill. Okay, so we want to color everything here. So we're gonna start begin, and then at the end of it, we're gonna type t dot end fill, end underscore fill. Now I'll run this so you see exactly what I mean. So if I run this now by pressing F5, so we finished the roof basically. The next thing we need to do now, as you can see, the turtle is pointing horizontally. We want the turtle to turn 90 degrees to point vertically downward and then move 200. We want to make it 200 because remember from there to there is 200. So we're going to make it 200 and then turn right 90 degrees and then move 200, turn right 90 degrees and then 200. So this, we wanted to do this basically 4 times. Okay, so to do this 4 times, what do? We use iteration again, like I said, because iteration basically, instead of writing the code all over and all over again, you simply just use iteration. Okay, so we use instead of using I, you can use J now or any other letter. For J in range 4. But please remember, before the turtle can draw, we have to make it turn. So sorry, you have to type t dot left dot right, t dot right 90 degrees. And so we say for J in range 4 colon and press enter. We can therefore say t dot fd 200, t dot right 90. So basically this will complete the wall. Please note that each time iteration is used, you must end the line for the iteration with a colon, and any line following must be indented. You probably won't know the exact position of the indentation. You just have to click in front here and press enter. Alternatively, if you have typed in the code and your code is here, you can press the tab key on your keyboard to indent it. Okay, so if I run this now, we should have the wall for the building. Excellent. So now we've completed the roof and the wall of the building. The next thing we're going to do is we're going to draw the door here. Now there are a couple of things I need to talk about when constructing the door. First of all, as we can see, the turtle is already pointing downward. So we will ask the turtle to move 200 to this point and then turn right. And after turning right, it should move 60 pixels. Okay. The reason why we're making this 60 pixels is so that if it moves 60 pixels here, at the other end, we will have 60 pixels, and the width of the door, the dimension of the door, the width, how wide it is, will be 80. So that we can add 60 plus 80, which is the width of the door, and then plus the 60 to give us 200, because this line from this point to this point is 200 pixels. So we're going to ask the turtle to move forward 60, and then turn right again, and then construct a square. Remember, to construct a square, we're going to ask the turtle to do it 4 times. Alternatively, instead of drawing it 4 times, you can make it draw it 3 times. It's up to you. So that when it turns and it goes, that will be 1, it will turn, and then we move 2, and it will go like that, 3. Okay, so that's all I'm going to do right now. Or alternatively, if you want it to turn 3 times, you will know from here it's gonna go up and turn 90 degrees. That's 1, 2, 3. It will end here. So let's make it do it 3 times, because if you make it do it 4 times from there, it will come back to the original position. But we want it to stop here so that we can move up here, and we can construct the estate for the building. So we're gonna ask the mouse now, the turtle, to move 200 pixels. Okay, so moving 200 pixels, so we're gonna ask the turtle to move. Please note, this is not gonna be part of the iteration now. We have to start from the beginning again, from the end here. So we're gonna type t.fd. So make this 200. Okay, and on getting to the bottom there, we're gonna ask you to turn right. T.right 90 degrees. So it will turn right, and then we want it to move forward. T.fd 60. Okay, and then we want it to turn right again. T.right 90, and then we're now ready. So as you can see from here now, the turtle is now pointing up, ready to construct the door, which is basically a square. Let's run this. See precisely what I mean. Okay, so it's pointing upward now. So it's gonna move. We want it to draw a square, but our iteration will be 3 because we want it to stop here. We do not. We basically want it to stop here. We do not want it to begin to return to the same position. So if we want it to return to the same position, then it has to be 4. The iteration number will be 4. That is the number of times the program segment will be executed will be 4 times. But now we're gonna make it 3 so that it will stop here. So that on getting here we can ask it to turn right. Okay, that's precisely what I will do now. So the next thing I will do right now is I will use iteration now to say for, you can say k, use another letter entirely different in range. For k in range 3, and then your indentation there, we have to say t.fd. Like I said, we're gonna make this it's up to us to decide. We can make it 80. Let's make it 80, because if we make it 80, then we know, because it's a square basically, we know 80 plus 60 plus 60 will give us 200. So we're gonna make it 80. So I'll type t.fd 80, and then we want the turtle to turn left. T.left is going to turn left 90 degrees, and now it should be pointing downward at the other side, at the other end. Okay, so I'll press F5 now. Brilliant. So we finished. Basically this is a single bungalow. Now if we want to create more bungalow to the left, side by side, all we have to do is to bring this turtle here back to the top, pointing horizontally the same way it was pointing initially before constructing the roof. So that if it's pointing this way, you can repeat that procedure, by turning 120 and then drawing the roof this way and going that way. Okay, so we're gonna construct 3 of these, but we can't do it at the moment. The turtle need to be brought back to that edge because we want it to be at that edge. If you want it to be at this edge, you have to bring the turtle to that edge, similar to the same position at the beginning before the construction of the roof of the building. Okay, so what we're gonna do right now, remember from there to there is 60, so we're gonna ask it to reverse. You use a negative value for the turtle to reverse there, and after reversing we want it to turn left, okay, 90 degrees, and then move 200 and then turn right. Okay, so we make it reverse 60. So what I'm going to do straight away now is I will go back. Please do not type your code under the iteration, because this iteration bit here, remember, this is for the door. Okay, so what we're gonna do, we're gonna move to the beginning again and type t.fd minus 60, because we want the turtle to reverse, and after reversing we want it to turn left 90 degrees. T.left, okay, 90 degrees, and then we want it to move to the top. T.fd 200, and on getting to the top we want it at the same position, the same direction it was before the construction of the building. We're basically trying to reset it. I think I will teach you how to reset later. So now we're gonna ask the turtle to turn right again. but the shortcut basically is a reset, but I don't want to use that for now. So turn right 90. Now let's run this and see what's gonna happen. F5. You see the turtle will reverse. See it reverse. You see. So now we're ready to duplicate this to the left, because as the turtle is pointing horizontally now, we can now ask it to repeat what we have done at the beginning here up to here. So it's gonna turn 120, draw the line 100, and construct another one to the left. Okay. To do this, we will use iteration. We need 3 of the buildings, and to do this, we're gonna go to the beginning where it says for I in range this at the top where it says t dot left 120, because the total need to turn 120. We want it to repeat the whole segment from there up to the end. So what we're gonna do is we're gonna type for P in range. We only need 3 buildings, so type 3 there, colon, and then highlight everything to iterate everything underneath this iteration, here, to repeat the whole thing 3 times. We're gonna highlight the whole thing underneath it up to let me just maximize this. We're gonna highlight everything up to here, and then we press the tab key to indent it. Press the tab key. Note that everything has been indented now, so that if we run the code now, 3 of the building will be duplicated. You see? Let me maximize this so that you see it. This is quite easy. You see, you can create as many as possible. If you want to create 4, you change your iteration to 4. You know exactly where how to do that. All you simply have to do is you will go over there at the top and change the number depending on the number you want it to repeat. So if you want it to repeat everything, the whole building 10 times, you put 10 there. Okay? And that's all we have to learn here. And to be honest with you, I've broken down everything I've been talking about step by step. Those are the dimensions. And down here, I drew the mouse, how it turns. This is the starting point. It turns 120, goes up by 100 pixels, turn left 60 degrees, draw another 100 pixels, turn left again 60 degrees, another 100 pixels, and so on. But as you can see here, because we were using the iteration, we decided the length of the slanting height should be the same as the length of the top of the roof. Okay, because we're using iteration. So it will go like that, go like that, go like that, repeating this 3 times, and end up pointing in this direction. So to bring it back so that it can draw that, we have to ask it to turn 60 degrees here, so it can draw that line there, and then we can fill that. And when it has finished that, it will end up at where we have the green turtle there, and then we're gonna ask it to turn right 90 degrees, move forward 200 pixels, and then 60, so that the width of our door will be 80. If the width is 80 and this is 60, we can have 60 at the other end, so that 60 plus 80 plus 60 will give us 200, because the whole line from there to there is 200. So it's gonna move At this point, we ask it to turn 90 degrees again, and then use iteration to construct that, and then reverse and go to the top, and then turn right and stay at that junction, so that at least we can duplicate the houses to the left. This is exactly what we've done so far. You can go through this explanation on your own. If you have any question, please write it somewhere where I can see it. You can email me, send me an email at emmanuel.oladipo@debbie-college.ac.uk. Now, all I want you to do right now is already I've included all the codes of what we just completed now. I want you to think on what you can do to analyze this. You can start with that one. No, you can start with the one at the top here, the story building here. Create one and then duplicate the story building to create an estate. Please, you need to plan everything well. Okay. If you're unable to add the window, leave it, because I'm still going to teach you something on pens up, pens down, and all that. So you can, just create the roof, do a thorough analysis of the roof. For instance, remember, the turtle will be pointing horizontally here, and here it has to turn 120. But on this occasion, there is no flat roof, so it is most likely going to turn 3 times. Okay, 60.